Okay. Experiment 4, determination of aspirin and paracetamol concentration using spectrophotometer.
Spectrophotometric analysis of commercial aspirin. The Beer-Lambert law provides the mathematical correlation between absorbance and concentration. It is usually stated as absorbance is equal to molar absorptivity times path length times concentration. The molar absorptivity is a constant and it is characteristic of the absorbing solute. The path length is 1 centimeter. Since the same cuvette will be used for all readings, the path length will be constant as well. Hence, the absorbance will depend linearly on the concentration over a specific range of concentration values of the absorbing solute. In this experiment, we will measure the absorbance of samples of known concentration and use these measurements to plot a standard curve of absorbance versus concentration. Then, using the standard curve and the absorbance of a sample of unknown concentration, we can extrapolate the concentration of the unknown sample within the range of the standard curve. In the first
يعني بالبداية بدنا نعمل بconcentrations معروفة من الأسبرين، بدنا نعمل calibration curve ومنه نقدر نعرف تركيز أي عينة مش معلومة التركيز للأسبرين.
First part of this experiment, you will make a 0.01 molar stock solution of sodium salicylate and use that stock to make 5 standard solutions, A through E, which will be analyzed using the spec 20.
اوكي، هون اذا رح نعمل اول اشي ستاندرد او سوري ستوك سوليوشن، هو ستاندرد لانه معلومه تركيز من الصوديوم ساليسيليت، وبعدين رح اخذ منه عينات اخفف ل تراكيز مختلفه لكنها معلومه، تمام؟ وبعدين اروح استخدم هاي التراكيز في جهاز السبكتروفوتوميتر واعرف الابزوربنس تبعها.
This is the apparatus we will be using for this lab. Remember to label all the glassware to ensure that you are organized. Begin by weighing out the appropriate amount of sodium salicylate needed to prepare 100 ml of a 0.01 molar solution. Remember to weigh the sodium salicylate by difference using an analytical balance. After the first reading, transfer the salt into a 100 ml volumetric flask and re-weigh the empty bottle using the same balance. Click the link in the description below for a more detailed explanation of weighing by difference and how to fill a volumetric flask. Rinse the funnel with distilled water to wash down any powder adhering to the sides and fill the volumetric flask to the mark. Once the solution reaches the bottom of the neck of the flask, use a dropper to accurately fill to the mark. Invert the solution 20 times before proceeding to the next step. You will be using the stock solution to prepare the 5 standard solutions. Next, use a more pipette to transfer the appropriate volume of stock solution into each 100 ml volumetric flask, as indicated in your lab manual. Pour the stock solution into a beaker before pipetting. Never pipette directly from the volumetric flask. You should also rinse your pipette before use. The second link in the description below provides a detailed explanation of pipetting. Carefully fill each flask to the 100 ml mark with the acidified 0.02 molar iron chloride solution. Invert each solution 20 times and record the percent transmittance of each solution as soon as it is prepared. Before using the spec 20, ensure that it is on for at least 20 minutes to allow the machine to warm up. Check that the wavelength is set to 530 nanometers and the mode is set to percent transmittance. First, use the left dial to set 0% transmittance. This should be done without any cuvette in the cuvette holder and the lid closed.
لاحظوا هون حاولوا يصفروا الجهاز بدون ما يكون الكيوفت موجودة. طبعا هاي المنطقة هون هي اللي رح نحط فيها الكيوفت. كل ما نحط الكيوفت لازم نرد نسكرها.
You will use one cuvette for all readings to ensure consistency in path length. Rinse the cuvette 3 times with distilled water and 3 times with the next solution to be measured before each reading. Ensure that you're rinsing all sides of the cuvette as shown here. You will use the FeCl3 to set 100% transmittance before analyzing your samples. Fill the cuvette to about 2/3 of the cuvette height and wipe the outside of the cuvette before placing it in the cuvette holder. Make a note of how the cuvette is placed in the holder. It should face the same direction for all subsequent readings. Close the lid and use the right dial to set 100% transmittance. To measure the percent transmittance of your standard solutions, rinse and fill the cuvette with the solution and place it in the holder. Close the lid and record the percent T value displayed on the Spec 20. Record the percent transmittance for all 5 standard solutions. You should analyze your standard solutions in a random order. Note the color gradient from flask A to E. As the concentration of sodium salicylate decreases, the color becomes lighter. From the data obtained from flasks A to E, construct a standard curve of absorbance versus concentration.
لاحظون
If you obtained
absorbance.
percent transmittance values from the spectrophotometer, you can convert them to absorbance using the formula A equals to negative log of T, where T is a decimal, not a percentage. After plotting these values,
اوكي هون حول بس الترانزميتنس. اذا لاحظتوا الجهاز قرأ ترانزميتنس ما قرأش ابزوربنس، مع انه بيقدر يقرأ ابزوربنس، هم طلبوا منه الترانزميتنس. بعديها طلعوا الابزوربنس من ماينس لوج الترانزميتنس، فطلعوه وعملوا بلوت بين الابزوربنس والصوديوم ساليسيليت كونسنتريشن، وهذا اللي معروف عنه او اللي معروف به الستاندرد او الكاليبريشن كيرف.
you must construct a line of best fit, which will be your standard curve. Ensure that the R-square value is higher than 0.98 in order to be considered accurate. Note that this is a sample graph. Your graph may be different from the one shown here. In the second part of this experiment, you will hydrolyze 3 aspirin tablets and dissolve each sample in a 100 ml solution.
اوكي هلا احنا عملنا الكاليبريشن كيرف اللي شفناه قبل شوي، وهذا هو، وطلعنا المعادلة تبعته. هلا بعديها بدنا نحضر 3 تراكيز غير معلومة من الأسبرين، ونروح نقرأ الأبزوربنس تبعها، وعن طريق هذا الكيرف بالمعادلة تبعته بقدر أعرف التراكيز اللي موجودة معي إذا طلعت الأبزوربنس تبعها.
In the second part of this experiment, you will hydrolyze 3 aspirin tablets and dissolve each sample in a 100 ml solution. Each solution will then be diluted again, and these solutions will be analyzed using the Spec 20. Begin by accurately weighing by difference 3 aspirin tablets. This is the equipment you should bring with you to the analytical balance room. Weigh each tablet individually and transfer to a labeled 125 ml Erlenmeyer flask.
بدنا نعرف تراكيز
Next, add
الأسبرين
20 ml of
tablets.
0.5 molar sodium hydroxide solution to each Erlenmeyer flask. Place a glass rod in each flask and place all 3 flasks on a hot plate. Gently heat the mixtures to a boil. Do not allow the solutions to boil vigorously, as that may cause splattering and loss of contents.
الهوت بليت حطوهم عشان تدوب.
Use the glass rod to gently crush any tablet bits that remain undissolved. If any solution gets on the sides of the flask, wash down the walls with a small amount of distilled water. This will help ensure that all the contents of the flask are quantitatively hydrolyzed. Once the solutions come to a boil, remove them from the hot plate and allow to cool to room temperature. Placing the flasks in beakers of tap water will help speed up the cooling process. Next, quantitatively transfer each solution into a labeled 100 ml volumetric flask. Thoroughly rinse the Erlenmeyer flask to transfer any remaining contents into the volumetric flask. Remember to rinse the glass rod and funnel as well to ensure complete transfer. Use a minimum amount of distilled water for this step, as you do not want to go over the 100 ml mark. Fill the volumetric flask to the mark using distilled water. Stopper and invert the solution 20 times. Next, pour the tablet sample into a beaker. Using a 2 ml transfer pipette, pipette 2 ml of the sample into another 100 ml volumetric flask and fill to the mark with the FeCl3 solution. After inverting the solution, measure the percent transmittance of the diluted tablet sample immediately. Repeat these steps for the remaining 2 samples. To determine the concentration of the unknown tablet samples, you can use the formula for the standard curve plotted in part 1 of the experiment. Substitute y with the absorbance of the unknown sample and solve for x, which will be the concentration of the sodium salicylate.
يعني هون إذا رجعت على هاي المعادلة مجرد ما طلعت الأبزوربنس بعوض مكان y و x هي الكونسنتريشن، فبقدر أحل المعادلة بمتغير واحد. أو الطريقة الثانية
You should also double check your answer visually with the graph. For example, in this graph, if the absorbance of the unknown was 0.3, then you could use the formula for the standard curve, which is shown here, plug in 0.3 for y and obtain a concentration of 1.613 times 10 to the power of negative 4 millimolar. Be sure to
طبعا هون ممكن برضو من الرسمة مجرد أنا عرفت الأبزوربنس بس بعمل على بمد الخط لللاين تبعي وبعرف الكونسنتريشن اوف unknown لكل تابلت حطيتها في التجربة تبعتي.